With that link, because I closed out all my windows because we already started. That link is in our.
Somebody throw that link to Chris, please, if you can in the
Appreciate you.
chat. Thank you. Here we are, block 19. Normally block 20 is when we give our little hurrah. So it's a little weird that we don't have our block 20 to end on here, but um, all the better. Some of you hopefully can go wherever you're going this weekend. And I hope that's great. We were supposed to go to Lake Geneva, which is in Wisconsin, just a little bit north of here. But my daughter spent yesterday throwing up almost all day. So I don't know where we're going to spend the weekend. Might be here. But anywho, I hope, we can talk more about this at the end of the session here, but I hope that I know this session has been frustrating at times. I know it is an immense amount of work, all of this, Damien and I know, but I'm speaking for Damien here and myself when I say we are very proud of the work that you guys have done and the time that you've put in, and hope that once the stress part wears off, right? Once it's not been 2 weeks of staring at these faces for, 8+ hours a day and multi-simming and tinkercading and everything else, you can look back on it and go, wow, this is good for me in terms of what we need, right? One of the big comments I've heard from people when they get back to their classroom is, I was really prepared to teach this class, right? I've walked into classrooms where they're like, all right, here's a book, and you don't really have curriculum to go off or whatever, and that's a pretty crummy experience. Here you've got a curriculum, you've gone through it, all that good stuff. So I hope that is good for you. Here we are with our capstone project here, basically, where we had the toll booth, we built it, it existed, and then we are now going to re-implement it with Arduino, which is the default project in the curriculum. Damien and I both said that sometimes we let kids kind of go off and do different projects here, or this and that, because the Arduino community is so awesome and you can grab a tutorial for anything and all that good stuff. But we want to go through this project itself, and it bridges the two worlds of kind of Arduino and the state machines, because you can sort of code it as though it's a state machine, and kind of use that same design ethos as you go through. So teaching coding. I know I've got a lot of coding teachers out there. I have never taken, how do I put this? I've never taken a class that I sat in for programming that I thought was well taught. When I was in school for programming a long time ago, it was, all right, day one, here are the 8 commands we're going to talk about today, and here's what they do. And day 2, here's 8 more commands, and like we didn't do anything with them until the end, and it was about data structures immediately and blah blah blah. And so the one thing I like about this curriculum here in DE is it gets right to it, right? Here's some code, press play. Let's see what it does. Now let's kind of deconstruct it. Let's try and change things. And I like that. But one of the universal things I have found with teaching coding is documenting one's code is something that people don't do. They don't want to do it. It is something after the fact, after they've got the program working, and they're like, meh. I had teachers in college that wouldn't grade your assignment if it wasn't commented. But what I do with my kids, the best success I have found, not only from them understanding what the heck they're doing, but from me trying to help them and documenting their code, is pseudocode. Okay, pseudocode. So pseudocode, if you've never heard of it, is, let me open up.
Well, Pseudo.
Yes. Thank you. Pseudo. So pseudocode is not code, right? So here I have Notepad, like the world's most simple application here in Windows. So pseudocode is, that's how you spell it, pseudocode. Okay. And I have kids write pseudocode, which is just English description of what should happen in their program. I'm not worried about syntax. I'm not worried about variable names at this point. Like, just write down what you think should happen, right? And so you just write it down. So we've got our Tollbooth circuit here, and Damien's going to go through it. So I'm only going to touch on, kind of pseudocoding here for a sec. Can you triple the font size? Sure, Alex. Somewhere, font 33 would be triple, but I can't. Oh, I guess I can. I'll do it custom for the math teachers in the house. All right, there you go. Tripled. All right. So I would say something like, when, are you gonna do one button, Damien, or two? What are you gonna do?
One button.
One button. When operator button is pressed, then I tell the kids, okay, so then on a new line, what happens when the operator button is pressed? I'm asking you guys, what happens when the operator button is pressed?
It
Gate
should
lifts.
open.
Gate.
Motor turns on.
Okay. So difference in language, right? I could say motor turns on or gate opens or whatever. That's fine. Okay. Gate opens. When does the gate stop opening?
When it hits the limit switch,
Okay.
the upper limit.
Gate hits the upper limit. Gate stops. Now what?
Gate stays there until the operator button's pressed again.
Okay, so gate stays there until the operator button is pressed again. And so now I would tell my kids, now you've got a little bit of a problem, because you're going to write when operator button is pressed, which we already wrote up above. So how do we distinguish those two? How do we differentiate them?
States.
Tell me about, what do you mean states?
For the first one, when operator button is pressed, it depends on what state you're in.
Okay.
If you're in state 0, it does one thing. If you're in state 2, it does a different thing.
All right, Alan, I totally hear what you're saying. Can you give me a little, so state is a little abstract,
It
if I
depends
didn't
on if
design this.
the gate is closed.
Okay,
When
stop right
operator
there.
button is pressed, gate opens.
Perfect. When operator button is pressed and gate
is closed.
You like that?
Yeah, it's
Okay.
good.
When operator button is pressed and
Gate is open.
gate is open. So the pseudocoding at this stage, we can kind of see like, oh, if I wrote the exact same thing twice, I'm probably gonna have to do some differentiation. And what I did, what I snuck in there, I'll wily like, what I snuck in there, a little Boolean operation, a little Boolean, snuck it in there.
I wish I could do those accents. I can't.
I can
Damien's
see-
actually from Jersey, but he's got this French accent thing. He's fooling us the whole time.
Damien's from Jersey?
Yeah.
What part? Where'd you live, Damien?
No, what's funny is that when I travel, go Midwest and everything, one of the first question ever is say, "Hey, where you from?"
Mhm.
And usually I say Southern California. Can't you tell by the accent?
And us Midwesterners be like, wow, really? Okay, I didn't realize.
No.
Wow.
I know exactly what people mean when they ask, but
Mhm.
it's funny.
All right, so let's see. Let's finish this up. When operator button is pressed and gate is open, gate does what?
Gate closes.
Gate closes. Anything else you guys want to put in here, or is this pretty good for right now?
One more.
What,
Yep.
what do we got?
When
Gate hits the lower limit.
Okay. When gate hits lower limit, and that's different than the one above, so I don't feel like I need to specify that. What happens?
motor turns
Stops.
off.
Motor turned off, gate stops, whatever the case may be. Okay, so here's what I do with this code, guys. Here's what I do with this. Okay, I'm going to take this code, I'm going to copy it, and I'm going to put it right in the Arduino editor, exactly as it is. The Arduino editor is going to hate that, okay, because it's not like actual code, but that's all right. No big deal. Let me open up Tinkercad here. I'm just going to throw an Arduino in here so I get my editor. And by the way, in your classroom, you will likely not use Tinkercad. You'll likely use the actual hardware Arduino. So the coding environment is a little bit different. but everything code-wise is the same. All right, so I'm just gonna get rid of all this stuff in here and just gonna paste in my text. Okay, so Arduino is freaked out right now because it doesn't know what when is, and it doesn't know what button is, and it thinks it knows what operator is, but that's not what I meant. But that's fine. So what I'm going to do is I'm going to comment out these lines. In the actual Arduino editor, there is a keyboard shortcut for this, so I don't have to do it by hand, but that's okay. It took me all of 5 seconds. Now, as a teacher, if a student wants help, which part of this do you want help with? Do you know how to do this when operator button is pressed and gate is closed? No problem. Let me sit down and help you with that. It'll take us 2 minutes to talk about that. It is not, I don't know what to do. I don't know where to go. I don't know what, you know what I mean? It's too big a question. They don't know how to filter down and ask the question. And this helps guide that, right? And then when they've done gate opens over here and they say, I don't know how to do gate closes. I say, well, why don't you go back and look at gate opens and see kind of how you made that happen there. What do you think you could change, right? And so they're going to have their code, right? Like, I don't know, they're going to write while, digital read operator equals high, whatever. I'm just making stuff up. Then guess what? They already have comments in their code. They didn't have to go back and write them. They're already there, at least in some regard. And when they are trying to figure out what the heck their program does, they have these little kind of marks along the way, these little placeholders that say, this is what this part of the program is supposed to be doing, right? So it's easier for me to see. It's easier for them to see. This has been the best solution I've come up with so far. Not saying that there aren't better ones, but for me, this is the best one I've come up with, whether I'm doing VEX and POE, whether I'm doing scripting in my computer class, or whether I'm doing this, having them type pseudocode first, boop, boop, copy, paste over, turn it into comments. That gives a structure to begin with.
Also helps you, it's almost, not only does it help you program by taking bite-sized pieces, but it's self-documenting.
Totally. My biggest problem teaching coding, and Bob, I'll get you 1 sec, was that a kid would say, my program doesn't work. And I would sit down and it would take me 5 minutes to read through their code and figure out what they were trying to do before I could help them fix it. And now I'm only looking at, okay, what are you trying to do? Is what you're doing accomplishing that? Bob, what were you gonna say?
I was just gonna say, once you copied it and pasted it in, what did you have to do to get it?
Oh yeah, I didn't even tell you. You put 2 forward slashes in front of the lines. That's called commenting the code, and it means the compiler ignores it. So 2 forward slashes comments out the code.
So I was writing when you copy and pasted. When you copy and pasted, it all went in, and did it put the voids in, and then you just put the double?
So
Hash
when
marks
you open up a Arduino coding window,
That's right. It always has that to start, right?
it has the void set up. It has the void loop, and so I just pasted it in void loop because that's where the majority of your program is going to be. And I presume Damien's going to talk about that when I turn it over to him. So. Okay. So any other thoughts, comments? I know we got some coding people in here. Any?
I've never looked at code before in my life.
Okay.
Never had a conversation about it once. So just a
But
heads up.
it-
on
How do you get into your garage? You know, code?
Andrew, coding,
I lift it from the bottom because I live in a very safe area.
Andrew, coding is easy. It's like you're talking to the machine, except
Yeah.
the machine doesn't understand English. So
Yeah, so just really simple.
I think that's a great way. I never I code, or I teach coding at the high school and collegiate level. And I don't know, I need to find a program where you can just do that, like add comments like that into it. But yeah, just having them just simply just say exactly what you mean, as simple as possible, and then just go forward.
Yeah.
Can I ask a non-serious question, but sort of serious? I actually
Sure.
want to know.
Sure.
All right, since Damien's French, if you were coding in France, what would your Arduino code, I mean, would it be using the English words that we see as the syntax?
Everywhere in the world, we use English when coding.
Really?
Yep.
Okay, thank you.
America. British imperialism.
Mm.
All right. So I think that's all I have to say about pseudocoding. Like I said, it works in the Arduino editor. It works in the I'm pretty sure it works in the new Vex code. They just switched their platform over last year, so I don't think I've tried it. But one last thought on that. When you comment, my coding friends out there know that you can block comment as well. So what you could do is you could do like a / asterisk / and that puts all of that in a comment, but that's actually not what I want here, because I want to like separate each line out. You know what I mean? I want to code in between. So yes, there is a block comment, but that's not what I want, because then I can't split it all up like I want to. So I want individual line comments. Maybe some folks out there are going to tell you they like to code back here and have the comment to the right. Fine, I don't care. I like to have one line comment, next line, what I'm trying to do. That's just me. That's my style. Okay. Damien is now going to take us through specifically some thoughts on how to create the toll booth with Arduino code.
Yep, I will do that. But before I do that, I just want to take 2 minutes to share with you a little Tinkercad thing that I did this morning. And I shared it in chat right here. It's a Tinkercad. And I'm going to now share my screen to show you what it does. Okay. So can you all see this thing right here, right? So if I start my simulation, look at my 7-segment display. 1, 3, 5, 7, 0, 1, 3, 5, 7, 0. So I just made a little counter right here. Okay. Why those numbers? I don't know. I just decided to put numbers. But what I like about this is that I made the code such that at the bottom right here, you can just say with what number you want for the first number in your count, second number in your count, third, etc., etc. For example, if right here I wanted a 4, I just press 4. If right here I wanted a 5, I put 5. If I want 6 right here, I put 6. And if I want to go back to 2 and then to 1, I just do that. And when I start the simulation, it just follows that 4, 5, 6, 2, 1. Okay. So basically, there are different levels of coding, you guys. There are the brute force coding when you control everything step by step like this. Then there is a slightly upper level where you make it a little bit more elegant, and then even more elegant, and then user-friendly, flexible, and everything, you know? So the point I'm making is that with a structure that, like the one that I chose right here, you can make this really quite simple, okay, for the operator to change everything. Now, the programmer, you in this case, the code generator, you would need more work to do what this can do than you could do otherwise. But this is really good. So this is actually quite advanced. So I'm not going to talk about it because many of you have very little experience coding and I don't want to scare you off. But it's a good program. I wanted to share it with you so that when you start feeling comfortable with that, you can look at the structure I followed and you can essentially study it to make it yours like that. Okay? All right. At this point, I'm going to go onto my iPad and I'm going to reopen the document from yesterday that we used to create the toll booth. Okay, so you should recognize this right here. Okay, but I just want to go through that again. So remember, we talked about the push button from the operator. We called it P, right? The upper switch right here, we called it T for top switch. The bottom switch right here, we called it L for lower switch. And we define closed for state 0, opening for state 1, open state 2, closing state 3. Okay. When we do Arduinos, we don't care about flip-flops. Okay. All of this is going to be done from code. Okay. Between this and the Arduino, the approach that I'm going to share with you, I changed one little thing. Okay. What we're going to do here with Arduino, the outputs, I'm not going to use enable equal 0, 1A equal don't care, 1B equal don't care. I'm going to just have the enable always on, okay, on my motor driver. And I'm just going to decide whether the motor stops by putting 0, 0 right here, goes in one direction, 0, 1 right here, make the motor be used as a motor brake by putting 1 and 1 right here, and the other direction by putting 1, 0 right here. Okay. So all of this right here, we don't need. All right, let's go over the Arduino code now. Okay. So when you code in Arduino, you're going to have 3 parts. In the structure of the code will have 3 parts. The first part, you're going to define your variables, your constant, your characters, your integers, things that you will need. So for us, since in our project, we're going to have an operator button, a limit switch, another limit switch, since we're going to have the outputs for the motor driver, we need to define all of this at the beginning. Okay, so this is what I'm doing in my first part of my code. Literally, I'm commenting right here, let us define some variable. And I say that integer P equal 2. What does that mean? It means I'm connect the output of button P to the pin 2 in Arduino. So I'm going to have a physical button, you know, for the operator to push. And so this button, if we use a SPDT, one of the 3 pins is going to be grounded, one of the 3 pins is going to be powered, and the 3rd pin is going to be my signal pin. Well, that signal pin is going to be connected to pin 2 in my Arduino. Okay, I'm doing the same thing for the limit switch T equal T, and T I'm going to plug it in my Arduino on pin 3. Same thing for my lower switch 4. And right here, I'm going to have an integer A. So this A right here will correspond to the 1A on my motor driver, and this B will correspond to my 1B on my motor driver. Okay. And since I'm doing a state machine, I need to also have a variable that I call state, but this is just a variable. It's not something that is going to be connected to anything. Okay. So what do I do with that? Well, right now I need to start thinking about everything. So imagine this, you guys. Okay, imagine that this is my Arduino board like this, and this year during distance learning, that's how I taught this kind of things. I had that little picture, and if I zoom in my Arduino right here, you see that I have my ground right here. I have my ground. So what I'm going to do here is I'm going to connect the ground of my Arduino with a little wire like this. I'm going to put it to my breadboard, and then I'm going to put that in my breadboard. That way I don't forget it's grounded. I'm going to do the same thing for my power. So I'm going to put my 5 volts right here, and I'm going to put my 5 volts right here. That way everything is powered, grounded. I'm ready to go. Okay. Then I'm going to have a little switch right here. Okay, so I'm going to have my little switch right here. This little switch, that's going to be my operator switch. So it's going to be my P switch. And so it's going to be connected to power. It's going to be connected to ground. And the signal has to be going to the pin 2 on my Arduino. So pin 2 on the Arduino is up here. And so the middle right here is going to be connected like this for my switch P. Does that make sense to you guys? Yeah. I'm going to do the same thing for the other switch. So this is going to be my switch. I'm going to write it below instead of above. This is going to be my switch T. This is going to be my switch L. So it's going to be grounded right here. It's going to be grounded right here. You're grounded. No. Yes. This is going to be powered. This is going to be powered. And then we're going to have the signal. So the T switch is going to be to number 3 on my Arduino. So I'm going to have a wire to 3 right here. Whoop, for my T switch. And I'm going to have a wire to 4 for my L switch. So 4 right here to the middle. Are we all understanding what I'm doing so far right here for you? Right? And we're just wanting to make the connection between the code and what we're going to do on the board itself. Okay? Then what are we going to have right here? Right here, I'm going to draw my motor driver. Okay, so this is going to be my motor driver. Okay, so that's my motor driver right here. Okay, and I'm not using the enable on this, so my enable is always going to be right here. That's my enable pin. It's going to be connected right here. Okay. To the right of it, I'm going to have my pin A right here. Right here, I'm going to have another wire to power everything. In the middle, I'm going to have 2 wires to connect to ground. Okay. My motor is going to be connected to this pin right here and this pin right here. So I'm going to just make a little comment right here. My motor is going to be connected to this and this right here. Okay. But what's more important is this one right here. This pin right here and this pin right here are what I have called my A and my B output over here, my A and my B. So this one pin right here is going to go connected to pin 5, and this pin right here is going to be connected to pin 6. Okay. So I'm going to take my wire like this, it's going to go like this on my board. It's going to go over there, and A is pin 5. Pin 5 is up here, so I'm going to go like this, right? And I'm going to change color so that it's easier to see. And pin 6 is going to be connected to the other one. Pin 6, there you go. Okay, so with all of this, our connections, our physical connections are done. Okay. Are there any comments or questions at this point?
I might actually write in the comments that that's an output pin as you're defining the variable, just so that you remember to set it to an output pin.
Okay, so right now, I have only defined those letters, and because of the numbers that we have right here, I connected the hardware that I need to those different things. Defining them as input and output is the second part of the code. So far, I've shown you only the first part of the code. The second part of the code, and you're absolutely right, is this one, Denise.
Yeah, I just meant in the actual comment above, because it says, see how you write, it's the output for
Right
motor
here?
or whatever. I don't know, just like for students to not miss that that's actually an output from the Arduino.
Yes,
So-
okay. Yeah, so the pin number 5 right here will come out of the Arduino to control the thing. So what I'm going to do here is I'm going to put some arrows right here to show that it goes toward the motor driver like this. So I'm going to put arrows like this to show that it goes toward the motor driver. And the switches like this, I'm going to put arrows to show that the switches are sending signals to the motor driver. Does that help like that?
Yeah, I can see that misconception because it's going out of the Arduino. It's an output from the Arduino, but it's an input to the motor driver. So I can see that being confusing.
When you write the code, it's from the perspective of the Arduino. Okay, so that's what we do in the second part of writing code, right? We're telling the Arduino, you are going to use the pin 3, the pin 2, the pin 3, the pin 4, the pin 5, and the pin 6. And we're telling the Arduino, on pin 2, 3, and 4, since we're going to have switches, expect an input. And this is what I'm doing here. For the push button, the top switch and the lower switch, those are going to be inputs.
Quick question on your H bridge right there,
Yeah.
your motor drive.
Yeah.
Those green dots are where it actually would go out and connect to the motor. So those would be the
Yes.
physical connection.
Yes,
to the
you're
modem.
absolutely correct. You're absolutely
Okay.
correct. Yes,
Just
yes,
double
yes.
checking.
No, you're absolutely right. And we are telling the Arduino on pin A and B, which are the two right here. Those are going to be outputs. Okay. Now, I don't know if yesterday you remember my big dire warning about the Arduino board. This is the Uno. This here right here is something that you can literally remove from the Arduino board and replace in case it's destroyed or damaged or something, right? And the reason this might be damaged are those two pins right here, the pin 0 and the pin 1, where it says RX and TX. This is for receiving signals and transmitting signal. R is receiver, T is a transmitter. So those pins, upon booting up, upon powering your Arduino, are going to be checked by this to see if there is another operating system that needs to be loaded into this. Remember, this is like a computer, okay? And so if you connect something like say to the board, then the Arduino is going to say, oh, right, I have another operating system right here. And it's going to wipe its own memory and system and basically be useless to you. Okay, so my advice is those two pins right here, really emphasize to your students, don't ever use them. Okay, because it's really high hand. If you want to have microcontrollers communicating to each other, if you want a Pi connecting and communicating with the Arduino, you might use that, but even that, it's not absolutely necessary. So I would just say never use them. Okay, so second part of the code is defining whether our pins right here are going to be inputs or outputs. Okay, repeat. First part, you define all your variables, you make your decisions for how to call things, right? And where you're going to plug them in, and then you plug them in. Then you tell the Arduino whether they're going to be input signals or output signals.
So
The
Damien,
third part, yes,
you define those variables before the setup.
yes,
Sorry, that was a door slam. So that's intentional, correct?
yes, it is intentional.
Okay.
Now, you can also redefine the variables as local variables in your void loop, but I would just leave them as global variables by defining them before the setup. What do you think, Michael? Feel free to intervene, Michael. Like, you're the one who actually went to school for this. I'm self-taught, so, you know.
I get the feeling you're still better at it than I am. No, yeah, he's right. He's right. The void setup happens, the way I split is void setup happens once, only once, and void loop happens forever and ever and ever. So by putting things before void setup, that's like for everything, like you said, global.
Okay, so let's move on to the meat, essentially, of the code, where we actually tell the Arduino what to do with all of this. And that is where the pseudocode that Michael showed you starts being important. Okay, so let's try to draw the parallel between the different things. Okay, so what I have right here is this. I know that we start at state equals 0. How do I know that? Well, because over here, I said that state was going to start at 0. Okay, so I'm going to start in state equals 0. And so when my first line of code right here is if state equals 0, I know for a fact that state is equal to 0. So I know for a fact that this is going to be the case, right? Now, I don't know if you remember what Michael did that was super clever in his pseudocode. He wrote 2 equals right there. And right here I have 2 equals, and here I only have 1 equal. If you're a little bit used to C programming, you realize exactly what that means. Can somebody tell the rest of us what the 2 equals versus the 1 equal, how they differ from each other like this?
It's a question. The 2 equals is a question.
And this is an assignment. So here I'm saying, hey, is this equal to this? And here I'm saying, make this equal to this. Okay, so 1 equal means I'm going to tell you, do that. 2 equals is when I check. Okay, so this means if the state is equal to 0, and I know for a fact it is, then we're going to do all of this. because I have this open bracket right here and this closed bracket right here. They're lined up correctly like this. That means that if this is true, then I'm going to do all of this. Okay. And in basically in the all of this, first I tell what to do when we're in state 0. I tell what to do. And so here I'm going to make my motor driver at 0, 0. Basically in state 0, I'm telling my motor to not move. Does that make sense for the 0, 0 right here? Yeah. Do we understand? Digital write, that means essentially I'm going to make the pin A on my Arduino equal to 0. Digital write, I'm telling the Arduino, send a signal of 0 to pin A. And if you recall, pin A right here, the Arduino sends a signal of 0 to this one and send a signal of 0 to this one. So right here we have 0, 0. That means the motor is saying, okay, I don't do anything. It's free spin. That makes sense? So the first 2 lines of code for every state that I'm going to use right here tells the motor what to do. And I commented it right here. This line and the next mean that I set the motor driver to 0, 0. Those 2 lines are the outputs of state 0. My little comments right here. Okay. Now, this is what state 0 does, but how do we get out of state 0? We're going to check the push button P from the operator, right? So right here, it says that, please Arduino, go read what the value of the switch P is. Please read, digital read what the value of the switch P is. And if you find this value to be equal to 0, which is what happens when you don't push the button, then your state is equal to 0. Otherwise, else, make your state equal to 1. Oops, I forgot a curly Q bracket right here. State is equal to 0, else state is equal to 1, like this.
Can I interject one thing, Damien?
Please, please, please.
Super. What Damien just said is he made a big deal out of it, but it's even more important than that. Super common is kids will write if P equals 0.
Ooh, yeah.
Right. They'll write if P equals 0. And like at first it took me a hard time to it took me a long time to catch that error, but they do it all the time. They say if P equals 0. And in their heads, they're like, yeah, that means I'm asking what the value of P is. But they're not. Does anybody know what P is? If they ask if P equals 0, what's P right now? Anybody know?
Pin number.
Yeah, Damien, if Damien, you scroll up a little bit, P is 2. Right?
P
we
is
define
2.
P as 2. So we'll say, is P 0? No, it's 2. The program won't error. You know, it won't tell you you're doing something wrong because that's a valid question. But that I run into that all the time with my kids. So if digital read P, that's when you're actually reading it and getting a value back. That's a really, really common error.
In my code, I usually, in the line above that, I go digital read P. So I go P state or something like that. There's a new variable. Or just so that they can understand that that's a state. So P state or P value or something like that. It's a new variable. And then the variable you compare to that. Just so it's that separate step in their mind, they know that the digital read set's equal to that. And we always do the code that way so they can see that you're getting the read from that. And that's the variable you're comparing to there.
Thank you. By the way, Michael, I have not taken a roll today. Just saying in case you have. Okay. So yes, so I agree with Michael. This is one of the common mistakes that students make. Okay, because just P equal to, it's an address, right? So basically it's like go there. And then if you want to see what's there, you need to see what's there, see what the value is at that address, you know? So anyway, if the push button is equal to 0, then we're going to stay in state 0. But since it's a digital, P will be automatically only 0 or 1, right? That means that if state is not equal to 0, because this means if digital P is equal to 0 is true, then we do that. Otherwise, else, state is equal to 1, right? So basically what it does from the Arduino's point of view right here is we start in state equals 0. If the push button is not push, we stay in state 0 forever. And in state 0, what do? The motor is off. But if we push the button, we go to state 1. But the Arduino does the loop right here. So basically, it's going to start up here, and it's going to do all of this. And it's going to keep going. And it's going to keep going. And it's going to keep going. And then it's going to go back to the top of the loop. And it's going to keep going. And it's going to keep going. But it's going to do that super, super, super fast, right? So by the time it goes through the entire loop right here, it's just a microsecond, you guys. So if you push the push button, it will detect it and it will go to state 1. And then it's going to say, if state 1, oh, look at that. What do we do if we're in state 1? Well, state 1, we're going to be opening the gate. How do we do that? Well, the motor driver is going to be in 0, 1. Remember 0, 1? Yesterday we said it was going to open, right? So the Arduino is going to send a signal of 0 at pin A and a signal of 1 at pin B. And since it's connected to the motor is going to start doing its thing, right? And so in state 1, we are opening the thing. How do we get rid of state 1? Well, we are going to check the top switch. So this time I read the value of the top switch. So if the value of the top switch is 0, then I'm going to stay in state 1 because state 1 it's opening, right? So I want the motor to keep opening it until when? Until the digital read T is not equal to 0, and then we're in state 2. And again, I forgot my curly Q right here. I forgot my curly Qs everywhere because I just copied and paste and change a few numbers. And you can do that on the Arduino as well, copy and paste right there. Okay. And then in state 2, what do we do in state 2? Well, I didn't want the motor to be disconnected because the thing could then, due to gravity, fall back down. So I heard the comment yesterday. And instead of setting my motors to 0, 0, this time I'm setting it to 1, 1 to use the motor brake option of my motor so that gravity does not overcome the gate and it falls down by itself. So I put a 1, 1 right here. And I'm up in the up position in state 2. I wrote it down in my comment right here at state open. And so if the operator right here does not push on it, I'm staying on state 2. But if the operator push on it, that means P equal 1, then I'm going to go to state 3. And in state 3, I'm just going to close it. So I reverse the 0 and 1 from before into a 1 and 0. And I'm going to stop closing and go back to state. Uh-oh, did I make a mistake when I wrote that? Is that state equal 1 right here? I'm in state 3 right now. That means I'm closing, right? That means we do that when we're closing. And we're going to stop closing when the, is that the top switch that I need right here? I made 2 mistakes right here. Can we try to fix them? What mistake did I make right here, you guys?
One should be 0.
Yeah, instead of this, we need to go back to state 0 to go back to the start. And remember, we are closing right here, right? So when we are closing, what switch are we using?
L.
L. So right here, I need to have a L. And now it's correct. Okay. One more thing. Come on, iPad, do your thing. There you go. One more thing. This curly Q right here is lined up with this, which closes this if statement condition thing. This curly Q right here is the one that closes the top one that I've opened right here, and it's next to void loop. Okay. Now the compiler in Tinkercad will tell you when you have syntax errors right here. Notice that at the end of each sentence, I have a semicolon right here, and that I try to line up, even on my iPad right here, the curly Q brackets that I open and close. Okay, so I'm going to share this little document with you.
I mean, I have a quick question about that motor drive 1, 1.
Yes.
That's a thing with that chip. You do 1, 1, and it kind of locks it in place in state
Yes.
2.
Yes.
Okay, I got you.
Yes. Let me see. Did I describe that on top right here? No. Oh yes, I wrote it below the outputs right here, but during the explanation yesterday, but I erased it then. Sorry about that. All right. So let me copy the link here to this thing and let me put it in chat for you guys. Here you go. It should be available in chat now.
I've got a question that
Yes, sir.
it's purely curiosity, and if it's going to cause any confusion for anybody, just forget it. But does this integrate well with three-phase systems?
No. Well,
No.
with relay, you need relays and you need something else.
Mm.
You need to really isolate your Arduino from the three-phase because it's still a prototyping board. It's not very robust.
But do
Okay.
they have systems like
Oh yeah,
digital
much better.
systems
Like
that work with three-phase systems well?
yes, like when in my medical robot, right? All my prototyping, I did it with an Arduino board. I did all my prototyping with that. But then when I built the 5 production models that we sent to hospital for the nurses to try, I went to another microcontroller that was much more robust, protected, and stuff like this. Not hackable, not open source. Yeah.
Gotcha.
So yes, I didn't use three-phase because I was just DC system for the robot, so that it can be rechargeable. But yeah,
I was just thinking because most factories, I'd say like 99.5% operate off three-phase. So I didn't
I know.
how well this went over into the manufacturing world. As
yeah, I mean, you can use you don't use that
building automation.
microcontroller, but you use microcontrollers. So
Okay.
yes, they do interface with that.
Just to prove a point I made yesterday, Andrew, I put a link in the chat there. This is a great link, by the way, for teachers everywhere. This link is called Let Me Google That For You. And all you have to do is put in whatever you want. And then when you click on it, it will animate going to the Google bar, typing in what you say, and then pressing search. And so when your kids ask you a question that's easily Googleable, you can just send them this link, which is me giving Andrew a little bit of a hard time. But just like I said yesterday, the Arduino has such an amazing community. All I have to do is Google Arduino three-phase, and I see 50 results of people controlling three-phase with the Arduino. So it's so cool that every time someone's like, hey, can you use an Arduino to control your sprinkler system? I'm like, Arduino sprinkler system, enter, boom, 1 million results. So like it's out there, which is really cool.
Just don't do it commercially.
Yeah.
It's open phase, people are gonna hack it. All right, Michael, what do you want to add to that little presentation right here?
A round of applause.
Oh, okay.
Great job. So you are going to implement the Tollbooth on Tinkercad. Okay. And I will show you what that looks like. May I share my screen, Damien? Thank
I
you.
just stopped sharing mine. Yeah.
You're the best. You can use an H bridge. Damien showed us how to do it with an H bridge. And so there's an H bridge. Okay. Because that's how we've used it, et cetera, et cetera, et cetera. Now, I'm pretty darn sure that the VEX kit comes with a motor controller 29 VEX piece. Motor controller 29. It's a very close-up picture, but this thing is pretty small. It's a little box about yay big, and it has 2 wires coming out of it. Okay. I'm pretty sure it's in the DE VEX kit. I'm like 99% sure. And if you have PoE in your school anywhere, you should be drowning in these. Okay. Unless you just implemented PoE this year, because this is for the older hardware. Anyway, inside this thing, it takes power, and it takes ground, and it takes a signal, and it uses that to control a large amount of current. That is suspiciously familiar to what Damien told us an H-bridge does. Okay. Because in fact, that's really what's going on in here. This is basically an H bridge inside this little box. Okay. It takes these signals and you can use it to control your VEX motor. Okay. So the H bridge is an awesome option, but just throwing it out there, if you feel comfortable, you can also use this motor controller 29 to run your Tollbooth. The difference being that instead of sending two signals out to the H bridge, which Damien designed brilliantly and beautifully, you would use a library in Arduino. Now, I believe in the activities that you went through, if you already did that from last night, they introduced you to libraries. Does that sound familiar? Anybody out there? Do they talk about libraries? No. Okay. So no big deal. So in my code, I've got a little briefcase right here, a little file cabinet, and there are libraries that you can include. A library is just code that somebody else has written and sort of hidden it in the background, okay, to make your life easier. Not that you couldn't write any of this code yourself, of course you could, but it's just a shortcut, saves a step. And if I include this servo library, servo, S-E-R-V-O, servo, I can use those commands to work my motor. Just throwing it out there if that's something you'd like to look at in lieu of using the H bridge. That being said, in the curriculum, they use two different buttons for open switch and close switch, which is not a big deal. Damien used one button, totally fine. And so I would just get rid of this button right here. Boop. And, you know, the accompanying wires. All right. So now I see I have three buttons. I used push buttons. If you want to know why, Bob will tell you. So I use push buttons over here for my operator. This is P that Damien defined, top limit and lower limit. Okay. I put LEDs. Again, these motor opening and motor closing LEDs are not part of the spec. You don't have to put those in, but I like to put them in because that way, thank you. That way, I know if this is working properly or not, right? So let's say the motor doesn't move. I'm like, did I goof it up down here? Did I goof it up here? Or did I goof it up inside the Arduino, right? So if the LEDs are working properly, then I'm like, all right, I know everything up to this point is working. It must be something with my H bridge. Okay. And you as a teacher trying to troubleshoot with your kids, even better, right? Because then you can make that same shortcut. You can say, all right, the LEDs are working when they're supposed to. So I know then that it's just an H bridge problem. Okay. So anyway, so then you'd, like you said, just go in your code, oops, get rid of this library, and set your stuff up. So I kind of try to follow along with what he was doing. I put a state variable in there. I did all my pins. I put in these in the spec. I don't remember if we talked about this or not. In the spec, it asks for a light to light up when the gate is all the way open, and a light to light up when a different light to light up when the gate is all the way closed. And so I put those here too. One thing I don't have in this design, which would actually be great, a lot of you guys did, was put in LEDs on your QA and QB. So you could also see if it's doing the states correctly. That's pretty nice. But in the videos, the 421 and 422, 423 videos, you might have watched those last night in the It's Your Turn. Super handsome, charming guy, went through all those. But one of the things we talk about there is the serial console. This little guy down here, the serial monitor. This thing is so valuable for troubleshooting because it gives you information back from the Arduino as it's running. So for example, if I was in my void loop, I might say something like, serial dot print, print program has started, right? And then, if I run my simulation, It's bad because I put a bunch of things and I didn't talk about. So I was changing my old code to meet the new code. Let's get rid of this. All right. What is your problem? So this I totally did on purpose. You have to, the error handling in Arduino is not so great, right? I mean, it doesn't give you a lot of information. It says in void function loop, I expected a something before a something. Well, it's because I didn't put a semicolon at the end of this line, right? But unfortunately, it doesn't give you a lot of good information. So just throwing it out there. All right, so it's running. Okay, it's running. And in theory, this would be giving me some feedback here. I do need to do one more thing before it gives me feedback because I have to open this line of communication. Damien said, don't put anything on pins 0 and 1. Yeah, that's because I'm about to use them. Serial.begin. Got to put this in here. You got to put a speed down. 9600 is fine. Don't worry about, well, why did you pick that value? It's fine. Just leave that value. You're fine.
It's just a speed of communications between the Arduino board and the computer, you guys.
Yeah.
Okay, it's measured in baud, BAUDS. And with all the Arduino boards we're going to use here, we'll just leave it like that.
Yep, leave it alone. So you can see it's sitting here telling me program has started, but you know what? It's saying it a bunch of times. Why is it saying it a bunch of times?
Loop is forever.
Yeah. So this void loop, it loops, right? It goes and 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 it goes. And so maybe program is started isn't the best. Maybe I should say, program is started over or top of loop or something like this. I use this almost all the time with my kids when they have like if statements, if whatever is true, then now I'm in my loop, right? And I would throw in a little serial.print and I would say, I'm in loop 1. And now I can tell, did they get into the loop or not? Did it evaluate the way they expected it or not? So this is a super good way to get like feedback and see like, is the program doing what I think it should be doing? Some other editors have like breakpoints and things like that. But because we're sending this to the Arduino and it's just supposed to do its thing, right? You don't have to, it doesn't have to communicate with the computer. In fact, Damien mentioned this kind of in passing before, but Arduinos have non-volatile memory, meaning if you unplug it and you plug it back in, it remembers the code you had in there. So you plug it back in, it's going to have the code from before and it can sit there running it. It doesn't need to have a computer. So opening this line of communication is a extra thing, but man, is it helpful. Really, really, really useful. Okay. I think that's all I have to say about that. Any questions before we take a quick break? Quick break. All right, let's take a 5-minute break. We'll come back in 5 minutes. And then I don't think we have too much to say after the break either, but.
That was wonderful to see that after what I explained, because that's really reinforced this and put it in perspective in Tinkercad like that.
Okay. So after break, Damien.
So Andrew, I put a link in the chat for you, like
To the opto.
yeah, so an
isolator?
optocoupler, basically you just have a light that comes on one side and a sensor that sees it on the other. So all your signals are going from light on to I sense it. So current can never come back through because it's only sensing the signal through a light. So the sensor cannot produce the light and send something back. So no current can go backwards ever. So
okay.
that's built into a lot of motor controllers. So when you buy a motor controller, if you're going to control something heavy, or you're going to control solenoids or even relays, even with relays, look for the optocoupler. When you're buying it, just make sure it says optocoupler, because they'll build the boards for you and stuff. Just if you ever want to try and control something bigger, just look for that in the.
If I want to control something bigger, I'm gonna go my way.
I don't know, man. You might want to
Yeah,
like
just flash
have
forward to
like your
Andrew.
have these big arms moving to Christmas music or something, you know? Because
Oh yeah, see, to do that with relay logic, that'd be quite expensive.
Mhm.
But feel more comfortable at least. This is out of my comfort zone for sure.
We'll get into your comfort zone, Andrew.
Yeah, I tell my students
What,
that all the time because they sit down and just their brains just want to shut
But-
down.
the cool thing about this kind of stuff, Andrew, is that if you mess up, you don't kill yourself, number one, and you're not down hundreds and thousands of dollars like you do when you do three-phase and big
You know,
machinery.
I like to live life on the edge though, Damien.
When I worked for Crystal Geyser, so we had three-phase also, you know, I hated going into that room we had the big rails, you know, three-phase rails, and
Mhm.
you can
The
hear
buses.
almost the electricity. You can feel your hair go.
Mm-hmm. Yeah, I've worked at some power plants and changed out light bulbs. And as soon as you step in the metal bucket, you can feel the tingle throughout your entire body. But you're also around like 69,000 volts and stuff like that, which wasn't what I was working on directly, but I was just within range of it. Now everything was grounded properly, so I was safe.
Yeah,
But
but you still feel it. You see
yeah,
all that potential, that electric field.
yeah. But that's still not the scariest thing I've ever done as an electrician. The scariest thing is going 180 feet in a boom lift. Or I mean, sorry, not 180, 120 feet, which 60-foot difference still. But whenever you look down, it's almost like you're standing on the tip of a pencil.
Yep.
120 feet in the air because that metal, the metal, I guess, beam, the arm that extends you out. Well, it's a beam inside of a beam inside of a beam inside of a beam. So by the time that you get up there, you're like on a 6x6 beam and your whole bucket and everything. And I was working up at 120 feet on this building, and or it was a structure, it wasn't a building, but it was at a chemical plant. And I was the cage is about 10 foot, 12 foot wide on those. Well, it has to be because in order to work in one spot, I have to walk back and forth the whole time. So I'm rocking to the right, so I'm walking left to stay with my equipment, and then it's rocking left, so now I'm walking right to stay with my equipment. And but I was really, for the first hour or so, until I really began to trust that I wasn't going anywhere, I was white knuckled holding onto the edge, and then I take my screwdriver.
Remember, plus if you drop the tool, you have to go back down.
Mm-hmm.
Do you
We have
remember that
lanyards, tool lanyards that are
I
called-
shared with you guys that I used to teach a maintenance class for wind turbine technician, right?
Mm.
The first thing that the applicant had to do in order to go through the training, we had to go on the field and they had to climb up to the nacelle of the wind turbine. Because some people, they were paralyzed by fear because of the height, they couldn't do it. So why go through the entire training first and then realize that you can't, you know?
Yeah, they've got, I see video of some linemen that they take a helicopter up to what they're working on. So they take a helicopter up and they're double harnessed to the helicopter.
Yep.
Then they take, when they get to their height, which is like 300 feet in some cases, which is insane. 300 feet really is crazy.
You get
And
combat pay, right?
Oh yeah. Yeah, we get hazard pay at 75 feet. So anything above 75, we're at hazard pay. And there's levels to it, like 75, 100, 125. But these guys, though, unclip one harness from the helicopter, clip it onto the pole, step onto the pole, unclip from the helicopter, clip the other onto the pole. So, you know, you're 100% tie off at all times. You can't actually go down. But when you look down from 120 feet and what that looks like, I can't imagine more than twice that.
Andrew, even worse, there's some tech. They fly on the helicopter. There's a little platform. They sit on the platform next to the high power lines because there is no access. And then they work on them from the helicopter. So the helicopter pilot is right there and working on us.
Yeah, it's wild.
Crazy.
Some of the stuff they do. And you see, if y'all have ever noticed, whenever you have high power lines like the 69,000 volt, they're the taller towers that run across, like you'll be driving down the road and then there'll be woods next to your, depending on where you live. Here we have a lot of land. So, and then you'll just see a clearing, like a 50-yard wide clearing that just is a straight line of no trees that's surrounded by trees, and there's power lines. Well, if you ever see them clipping that, and how we do it is we get a helicopter and we basically hang a 20-foot chainsaw blade off of it. And yeah, from a cable, a tether, and we just fly the helicopter across, and it just cuts the trees. Like whenever they start to grow like wide, you know, we don't cut like, if there's an actual tree, we have to go and cut it out at the ground and take it out. But to keep it just trimmed, we just kind of fly the helicopter. Well,
Awesome.
we don't, but we're there cleaning up the mess that it drops, you know. But yeah, it's pretty wild seeing a 20-foot chainsaw hanging off of a helicopter right next to 69,000 volt lines, you know. Those are some skilled pilots. But yeah, I'd say my job is really cool.
You have to really trust that helicopter pilot too, because as you described it, at one point you were tethered to the pole and to the helicopter. So if the helicopter were to leave, just pull apart.
Gruesome, Michael.
Yeah. I mean, I presume the tether would fail before your body would, but
yeah.
Being drawn and quartered almost by a
Mhm.
helicopter.
That's right.
Yeah, it doesn't sound fun. And as far as the California fires, I don't know if electricity started those fires. I thought it was a gender reveal party that started that last set of forest fires. But I can definitely see not trimming trees as starting a fire like that in such a dry area. But I've never been to California. The furthest west I've ever been was Vegas. So, and I've been pretty much straight up and down from Kentucky, and that's about it. So
those gender reveals that get out of control.
yeah, they wanted to do fireworks, I think, and
Keep
one of them
it
landed.
simple.
Isn't that what? Yeah, keep it simple, stupid. That's what we always say.
We waited until the day off. So, oh, that's a girl. Cool.
Yeah. Well, we did they can actually do a test at 9 weeks now and tell you the gender via like the XX or the XY. So if it has the Y chromosome, it's a boy. So if it comes back as a boy, it's definitely a boy. But if it comes back as a girl, it could still be a boy. It just hasn't developed that Y chromosome or something. I don't know. My wife was telling me about it. She's smarter than me. And but we found out at 9 weeks that it was a boy. 9 weeks and 1 day, and we didn't hide it. We just FaceTimed everybody, told them, hey, it's a boy. We don't get fancy and playing parties like that.
All right, Michael, shall we start over again?
It'd be more fun if it was like St. Patrick's Day, where you dye it's a kegger and you dye the keg a blue or a pink, and you let the parents dye it. Yeah,
that'd be cool.
That'd be a better party. No fires.
Well, you see, the thing is, we can't throw parties for stuff like that around here because we party too damn hard. You know, I mean, if we threw a party for stuff like that, then everybody just be hungover all the time.
All right. All right. So it's I want to talk about a couple things here, because in theory this might be the last time we see some of you in a face-to-face sort of a setting here, face-to-face with quote fingers sort of setting here. First thing is, you may have already gotten a survey emailed to you. Usually it comes in through email. I'm seeing some nods, so maybe some people saw it already. I don't know. I don't know when they send it, especially with our weird thing here. But at some point, you're going to get a survey from Project Lead the Way, and they will ask you to evaluate the training itself, and then Damien and myself. So please make sure you do that. Number one. I don't think it would hang up a certificate, but certainly you don't want that to be the thing that means you don't get your certificate. But also, I know we use that information. Damien and I use it to get better, and to stroke our ego, obviously a big important part of that. And then to improve the training, right? So, and I was serious. I said before, you know, when you guys, after you guys have taught this for a year, you know, I would love to have some feedback and say, you know, I could have done with less of this. You know, we didn't talk about, you know, X, Y, or Z enough. That would be good stuff to know too. Check your, I'm just reading now, check your spam junk folders because sometimes the survey ends up there. It is coming from Qualtrics. So the email will come from them. If you have taken another Qualtrics survey, you might get a message like, this survey has timed out, or you already completed this survey. When this happens, you should clear your browser history, cache, and cookies, or paste the survey link in another browser to try again. Then the survey should work just fine. If you couldn't tell, I was reading the script that I was given on that. So there you go. Fall webinar. So Damien has mentioned a couple of times. In the fall, we will host another little session, optional, of course. It's not, again, not going to hold up your certificate if you're not there. But once you get into your classroom and you have your hands on the material, the hardware, that sort of stuff, we'd love to have another little sit down and kind of talk you through some of those things that you didn't get to touch, right? The MyDAC, we didn't really get a chance to talk about the MyDAC because you don't have them. And then, you know, the S7 programming that, maybe the VEX hardware, those sorts of things. So Damien's mentioned that a couple of times. So we will figure out, Damien and I will figure out a good time that works for us, or maybe a window of time. And we'll have another meeting then. Come with your questions or your hardware or whatever. And of course we'll record it so you can have it out to you as well. Things that are going to go away. Our community is going to go away. So if you have anything awesome on there, make sure you put it somewhere else. The core training course. So the It's Your Turn, the cohort connection, all that stuff is going to disappear in October. So again, if you've written anything in there, taken a note or whatever, make sure you have that someplace else. Things that are not going to go away. Our collaboration document is not going to go away. Our folders that were made, if people were throwing things in the folder that are linked to in there, that's not going to go away. Damien's YouTube channel and my YouTube channel, presuming we don't violate YouTube terms of service or something, those aren't going away. So those should be up there for the foreseeable future. Okay. If you're like, hey, I found this super cool video that corresponds to what we're talking about, let me know. I'll throw it on the playlist or whatever. Because again, sharing is great. There's one website I wanted to show you that we didn't get a chance to show you during Block 20. I remembered it after the fact.
There's also a website that, or something that I'd like to share. It's called Fritzing. Do you know Michael?
Yes,
Michael?
I do. Yeah.
Okay.
I had heard Fritzing was making some changes, but it is a really good website for making demonstrations and stuff.
Yeah, they have started to make it something you need to pay to get full access. So it's not as useful as in the past, but I still use it because I love Fritzing.
This is electronics-tutorials.ws. I don't know where WS is, but electronics-tutorials. And it's a really great resource. Okay. So, you can go back and watch the videos, you can read the content, but sometimes something's it's not going to click. It's not going to hit whatever, the way Damien and I taught it just didn't register. So there are some really wonderful resources. I'd say just about everything we cover in the class is on this website somewhere. We see binary numbers, we see Boolean, combinational logic. We've got sequential logic, and then lots of other stuff in here too, counters. So this is a really wonderful resource to kind of bolster your own knowledge, because as we said at the very beginning of the training, the expectation was not that you were going to be a master of this content by this Friday, right? It's to show it to you, make you feel more comfortable, make you kind of excited about sharing this with your kids, and giving you a point where you're going to want to, you know, round out your knowledge the more you get into it and the more you teach. So this is a wonderful resource. You want to talk about fritzing, Damien?
I just wanted to mention it before Tinkercad became what it is now. I use fritzing a lot to show wiring diagrams because I like to emphasize in my engineering classes technical writing, you know, and documenting. And before Tinkercad allowed you to do this kind of things, like similar to what we showed you with the connections and everything these 2 weeks, that was difficult for the kids to do something nice and neat. So I use fritzing. They have similar capabilities than Tinkercad. Tinkercad is free though. So check it out. It's pretty cool. It's really pretty cool.
Chat there. One other quick
Thank
one.
you, Michael.
Yep. This is outside of the curriculum a little bit, but Damien and I mentioned that one of the really exciting things you can do is let kids kind of go wild with the Arduino. So we stumbled across this website last year when we were looking for basically Tinkercad, and it's called circuito.io, circuito.io. And this is not a simulator. Read my lips, not a simulator. But what you do is you have your Arduino, okay? And then they have a whole bunch of inputs and outputs in here. These are real things that exist. And of course, they'll let you buy it from them, but that's beside the point, right? And so let's say I have a let's say a 7-segment display, okay? I just drag into my space, and here's what it does. It shows you how to wire it, which is pretty awesome, right? It shows you the hardware of how to wire it, which is pretty darn cool. And then if you hit code, it gives you example code for that piece of hardware. So this is an awesome jumping off point for kids who are like, I want to do a project that does blah. Well, start here, right? This is not done for you, but you know, this is a great place to start. And they can kind of look through the code. What I think is the most impressive piece of software here is I put in a 7-segment display, and I'll put in a humidity and temperature sensor. It shows me how to wire both at the same time, right? So they're both wired up. And if I go to code, it actually puts code for both in at the same time. You can download it if you want to, you know, but you could also just copy paste. It's probably easier. So anywho, I thought that was a really cool resource for if kids want to kind of go beyond the speculated Arduino assignments. That's a pretty neat little website. So, okay. All right. So turn-ins. When you complete your last turn-in, and Damien or I, but probably Damien, grade it, and it's complete. So once you have 20 blocks complete and your readiness training is complete, you should get a automatically sent to you certificate from Project Lead the Way. Okay, it'll send it to you, and they'll say, congratulations, you did it. You are certified as far as Project Lead the Way is concerned, which is great. If you don't get all 20 completed, or as I've had to happen in the past, you forgot to like click on something in readiness training, then you don't get that certificate. So if for whatever reason you don't get a certificate when you think you should, email Damien and I first. And if it looks good on our end, then we'll tell you, go contact training@pltw.org, because they'll have to take it from there. Alan, there's no turn in for block 20. You're right, Alan. Sorry. So block 1 through 19. Sorry. So that's that. We don't want to have to chase you down, obviously. So the idea is that they're going to be all turned in today, unless we've made some prior arrangement with you. So that's the expectation. I'm going to be around here for quite some time, for the next several hours at the very least. I'll probably be here till 5 or 6, and maybe even after that, depending on how pukey.
On that note, I will also be here very late today, probably around the same time as usual, but my mother-in-law just finally decided to retire. So we're going to have a late lunch, early dinner, and then I'll come back and I'll relog in. And so if you need help, I'll be back later.
Awesome. Of course, text us, email us, you know, whatever it is, and we can set up times. If one of us isn't on here for whatever reason, we can come check in with you. Okay. Questions that you guys have going forward.
This is probably a dumb question, but can you clarify the readiness training? Is that just like the little quiz questions and stuff we were doing?
So
in the
what was that?
I had the exact same question.
Okay.
Is it the stuff you're supposed to do before you come to the class that says, you know, complete, there's like 3 items?
Yeah, it was like introduction to digital electronics, introduction to multisim. They're like watching some videos and putting some stuff together. You didn't have to, let me be really clear. You didn't have to turn anything in
Right.
for readiness training. As long as you clicked on the things, it qualified you as done with readiness training.
So just the prereq stuff.
Yeah.
Correct.
Yeah.
So basically, I'm looking at it right now. The vast majority of you have completed in the prerequisite progress the getting started with digital electronics and the welcome to PLTW. Actually, the welcome to PLTW, everybody has completed it.
Good job.
All but 2 of you, I'm not going to name names like this in public, have completed the getting started with digital electronics.
So make sure you do that. Again, I've had that happen to my participants in the past. Where I'm like, everything's done. They're like, I did everything. I'm like, I don't know what to tell you. And then it was the readiness training. So, other questions?
So are you okay with us just using the template that you gave us and then doing the coding for this?
Yeah, there's no code in that template, but I don't mind if you use that template if you'd like to. It's up to you. It's not, certainly it could be a lot better, but I just slapped it together. And and big warning, I did not necessarily use the same numbers that Damien did where things are connected. So don't assume that wherever Damien told you the pin was is where it is, because it was based
You
on
will have to either move the wire if you want to keep the same thing as mine, or trace the wire that Michael did to figure out to which pin he connected them.
Yeah, for sure. All right. Well, Damien and I will be on, or at least I'll be on for the next 40 minutes for the cohort connection. And then at least 2 hours after that, I'll be around for the It's Your Turn while you guys work on this and get it going. I guess just, Damien, you have something to add?
No, I just opened the breakout rooms again if people want to,
Great.
to go in breakout rooms, you know.
So I guess then just the last thing from me, and I'll let Damien say his piece, but it's been really enjoyable for me. I mean, it's as enjoyable as teaching on Zoom is, as you guys, most of you know, you've all been teaching. So distance learning is never fun, but you guys have been great. It's nice to see a lot of faces. That's exciting, as opposed to, you know, black rectangles. So that's pretty nice. And you guys have been awesome about talking to us and giving feedback and answering questions when we ask them, and asking really great enrichment questions. And so just a personal thank you from me to you guys. I think it's been fun. Made some good new friends here. And as you go forth, I learned things from you guys in this training, and I want to continue to. So please share things with us, email, throw it in the forums. You can put it on like the actual DE forum. If you make something cool, you make a cool quiz or a project, or do something neat or different, or have a cool speaker come and talk to your class, or find a neat video, that makes us all better. So I implore you to share and share alike, because I think that's really important. And I hope to see you guys in the fall. Damien?
Yeah, so I wanted to thank you all for that as well, but I also wanted to thank you, Michael, because I've learned a few things from you as well, and it was fun to work with you. Thank you.
Right back at you, Damien.
And again, I'm not being sponsored by it at all, but that set of video lectures by that Indian professors, I cannot recommend them enough. They are gold. Okay, so there are 2 options at this point for you guys. Either you just focus on the Project Lead the Way curriculum, and it's completely fine, and you become quite good at it, you know, and it's wonderful. But you're an engineering teacher, okay, and there's nothing wrong with that. Or you try to go a little bit further and not become an engineer. We cannot become engineers in 2 weeks like this, but you keep educating yourself on the topics, and help your students grow as well as you grow yourself in the field. And honestly, I absolutely loved taking that first digital electronic class with Project Lead the Way a few years ago, because that reminded me of 2 classes only that I took when I was in college. And back then it was difficult for me. I didn't make connections. I was not mature enough, I guess, on too dumb back then when I was 18, 19. But this class in Project Lead the Way, when I was sitting where you are, opened a new realm of possibilities to me. And I kept educating myself to the point where I've developed skills, you know, without, it's not a humble brag or anything, but I became pretty good at this. And so I can better serve my students when they want to go beyond the curriculum and do very creative things. And the first resource for that is that series of videos that I shared with you. So again, I cannot make that decision. I cannot tell you, oh, watch them, they're wonderful. But I would strongly suggest that you do so, because really they were wonderful. So, and again, thank you for these 2 weeks. It was nice for me to get back to teaching digital electronics. Last year I did POE, and I like POE, but I prefer DE. So thank you, guys.
You don't have to whisper. It's the truth. Damien, can you put the link for the Indian guy professor's videos?
Okay, I'm going to go get them again, and I'll put them in.
Okay. So that's gonna close out the general session. Then keep in touch with each other. Use the community. Email each other. You guys made awesome, trial by fire comrades here. You guys have shared something pretty monumental here. I mentioned with date of birth that just because we all did it doesn't mean that it's not a big deal, because it's a big deal. A teacher from El Paso went through my training. He said, I thought it was going to, I was told it was going to be like slaying the dragon, and I slayed the dragon. I was like, dang right, you did slay the dragon. Good job. So there you go. Okay. If I don't see you guys, have a wonderful everything. And otherwise, I'll be around.
All right. Well, if I can be one of the first to ask for help.
Yeah, I'm here.
I'm having some problems with my motor controller. Would you like to go to a breakout room, or should I just show everyone? I don't care either way.
Yeah, let's do it right here.
All right. So is it showing this right here?
Yeah, I can see it.
All right. So whenever I hit my start simulation, my chip blows up.
Sure does. I see that. I see that.
Because
on top.
I didn't notice it did that.
Yeah, you're putting 24 volts into the logic pin of that thing, maybe? No, you're not. I lied. You're putting 5 volts in.
It's this pin right here. If I delete.
Yeah, well, that's power. You
Right.
need, that's enable, excuse me, that's enable. You need power to the top left chip. That's enable, but the one above is power. So that one needs to be powered. So let's go ahead and run that up to 5 volts. And that may fix your problem, because you got kind of a weird ground differential there. Yeah, there it goes.
All right. Thank you.
No problem.
Okay, I have a question too.
Okay.
I was following along with Damien when he was like drawing everything on paper for this toll booth. And so I feel like I have it wired right, but the code isn't working. And so then I tried on the one that you just sent out, Mike, and the same thing, I'm getting the same error.
Okay.
So
let's take a look.
Okay. So this is what Damien built by hand, but then I have this whole thing. So where it has the error is on line 26.
Okay. Too few arguments. If digital read P is 0, then digital write B.
Could you scroll up? I'd like to see the top of your screen right here. Yeah. P equal to, P is an input. Okay. Okay, we can go back down then. It's not accepting that. That's weird.
1. Digital read T is 0, stay in state 1, otherwise go to state 2. And here, copy.
Do I have a typo or something? That's the only.
I mean, I don't know. That's what I'm looking at. Digital read P.
V.
Digital write. Oh. Yeah, it's Damien's pseudocode kind of translating into supercode here. So where's my annotate tool? Try something like this. Try digital right.
Are you typing on my screen? I can't.
You'll see it in a second. I just have to hit enter. It's a Zoom comment thing. Try something like that instead of equals 0.
Oh, there. Okay.
Oh, yeah. So sorry. I should have mentioned it.
With the semicolon at the end.
Up. 2 lines up. Yep. It's the digital right.
Yeah.
That's one of the biggest problems with Arduino is it like highlights line 26 and 27 as though that's the problem. But I believe the problem is above and like.
No, you're absolutely right, Michael. That is the problem. Yeah.
Wouldn't it be low though?
Well, whatever. Yeah. I mean.
Yeah, low.
Okay.
Yes, you're right. Instead of 0, it would be low.
Okay. And so then do I need to do the same thing here with digital read?
Oh, that one's okay. No, that one's okay. Because you're asking the question.
Okay.
Let's try that. Let's see. Okay. No errors, which is good. Exploding chip. We call that the Josh. Only because I just showed him what's doing that. You missed the pin 16, top left corner. That needs to be powered.
Okay. So.
Is your simulation running? So what's the 4th of July? I like to blow stuff up.
Okay. No errors, no explosions.
Woo. All right.
Good for now. Thank you.
No problem. Josh, you guys have cooler fireworks in Indiana, I think. Illinois is definitely the most restrictive fireworks state.
So my stepdad, for years, he's known like the backroom manager of a fireworks store. And so he's gotten access to stuff. But he decided to get rid of the middleman, and he has his like explosives license. So we usually get a fireworks show that rivals most small communities in like my mom and stepdad's backyard or front yard. But this year with all the shipping, like that whole like thing that got blocked in the channel or whatever, it delayed fireworks to us, and so we may not get to have our show this year, unfortunately. Oh, no. So democracy's at risk.
Thanks, Canal.
Right. I wasn't too worried about it earlier this year, but now I'm really upset.
All right, Kirby, you want to jump in a breakout room, or you want to do something?
Sure. Okay. Just breakout room 1, will that be fine?